Okay, this presentation is using simultaneous equations and solving for both x and y. Okay, you may recall your work from linear modeling, where occasionally you'll have two linear relations or two equations plotted on the same axes on the same Cartesian graph, and they do eventually intersect at some point, which tells you something about the relationship between the two equations. The whole point of simultaneous equations in this particular part is to not use graphical solutions, not yet anyway, and solve them using algebra. So you'll do notice that with this example here that they do cross over at a certain point, and these two solutions, or these two equations, 3x plus 2y equals 18 and y equals 8 minus x, do have a common solution at approximately 2, and if I've drawn it relatively well, 2 and 6. And you can tell that just by looking at the graph. Okay, so in the next section we're just going to see if we can solve this in another way, an algebraic way. Okay, from the previous example you saw that we had two equations, 3x plus 2y equals 18. Now, that equation on its own will have an infinite amount of x and y values that will make this equation true. In other words, I could choose, using a different colored pen, x equals 0 and y equals 9. And if I substituted x equals 0 and y equals 9 into that equation, that'll be true. So I could also have x equals 6 and y equals 0. And if I also substitute that into that equation, that will also satisfy it. That'll equal 18. Also, if I put x equals 4 and y equals 3, that pair substituted into that equation will also equal 18. So I could keep going. There's literally an infinite amount of solutions that will make that equation true. On its own, that equation won't help us very much. But if we were to have another equation, which we did, which you saw when we drew it, 8 minus x, or y equals 8 minus x, that actually narrows it down. That gives us an idea that these two will share one solution at some point. And we call equations like these simultaneous equations. And our first step will be to solve them using the method of substitution. Okay, so on this page we're just basically setting out really. There are two ways, well multiple ways of actually working out two simultaneous equations. One is by substitution and one is by elimination. So our first method, the method that's covered in this presentation, will be on substitution. Okay, here are a couple steps on how we can approach solving simultaneous equations using substitution. Our first example will be the one that we started off with the two equations that we plotted at the start of the presentation. So it was 3x plus 2y equals 18 and y equals 8 minus x. Okay. Just going with the dot points here, it states in this first dot point, write one of the equations so it is in the style of variable equals. What that basically means, if it isn't in this form already, make it in that form. In other words, make y equal something or x equal something. But when we start in this exercise, we're pretty much going to be given y equals 8 minus x or x equals something as well. So that'll be done for us for the most part. Replace, i.e. substitute that variable in the other equations, which we're going to get to, and solve the other equation. So the next two steps will be shown on the next page. Alright, so before we solve this these simultaneous equations using substitution, we're actually going to start by labeling both equations as equation 1 and 2. This will become a little handy later on, and it helps in explaining what's actually being done. Now, up to this point, your knowledge of substitution probably involved substituting a single value into an equation and solving that equation after that for another variable. So this is slightly different, but the same method. In other words, we're given a value of y, but the value of y that we're given is in the form of this equation here, equation number 2, y equals 8 minus x. So we do have a value for y, but it is in an algebraic expression. So knowing that value of y, and knowing that we have an equation above that, equation 1, that has two unknown variables, we could take our value of y and substitute it into equation 1. So what I mean is, just going to state this at the start, I'm just going to write substitute equation 2 into equation 1. Okay, so I'm just stating what's going to happen now. So because I'm going to put the expression of 2 into equation 1, I'm going to write 1 again. So I'm going to write 3x plus 2. Now, you'll notice that it's 2y, and I do actually know what the value of y is. So I'm actually going to replace y with the expression, with the value that it is, which is 8 minus x. So instead of putting y, I'm going to go 2 multiply, open a bracket, 8 minus x, and we know by now that between the 2 and the actual brackets are multiplication, or multiplication takes place, so that'll equal 18. Okay, so what we have here now is an equation with a bracket in there that I probably need to simplify or expand. So I'm going to take that, I'm going to rewrite the line underneath, 3x plus. Now, you know through your work in expanding brackets that you'll take the 2 and of course multiply it with the 8, which is 16, and of course taking the 2 again and multiplying it with the coefficient of that x, which is not written, but you know that it's 1. So it's going to be 2 times negative 1. So that'll be negative 2. But not just negative 2 or x. Equals 18. Alright, so we're getting closer to what we need. Right now, on the left-hand side of that equation, the last one that we've just written here, we have to simplify that. In other words, I know that there is an x here and an x here. So I'm going to try to combine those two and eliminate the number of terms that I have. So I'm going to go 3x, take away 2x. So this is your work from like terms. So 3x take away 2x is 1x, or just x. And the only thing left is plus 16. And that'll equal 18. Okay, so again, coming down to our last little bit of the solving equation, I want to know what x is, so I'm going to take away 16 from both sides. Okay, which only leaves x, and of course 18 take away x, 18 take away 16 is 2. Right, so that is one solution, or one part of the solution, half of it in fact, because you'll need to know what the y value is, so you have the x value here. So to find the y value, we're going to need to take that value of x, which we know, and substitute it again into one of the equation 1 or equation 2 to find out what y is. So logically, you'd choose the easiest one that would require less working out and less chance for error. So I would think that subbing your value of x equals 2 into equation 2 would be a sensible idea. So I'm just going to write sub x into equation 2. Alright, so I'm just going to start out with equation 2 at y equals 8. Takeaway. Now, it says x as it is, but I'm not going to do the x, I'm going to replace it with the value that I know x is now, which is 2. So my y value is going to be 8 take away 2, which of course is 6. Which means that, after all that, our final solution, the solution for which both of these simultaneous equations are true, would be for x equals 2 and y equals 6. So, and if you remember the graph that we drew at the start of the presentation, you'll notice that the two lines of these two equations, when they crossed, was at x equals 2 and y equals 6. So this proves that that method is correct. Okay, so just in summary, in solving simultaneous equations using substitution, you will have noticed by now that the two equations that you do have, one will have two unknowns in it, an x and a y variable, which we've talked about before, has just on its own an infinite number of solutions, which you can't solve. But if you have a second equation that is in the form of y equals, in this case, y equals 2x plus 3, or y equals any other expression, you'll be able to use that second equation to help you find what the both x and y value is for both of these linear relations. So it's just a simple matter of, if you recall from the last step, of substituting equation 2 into equation 1, okay, and then solving for x using the steps in the previous slide. So once you've solved for x, you need to find what its corresponding y value is. And your answer will give you a solution of x and y that is common to both equation 1 and 2. So good luck, and try some exercises to practice your skills.